We're going to look at 4 different types of miscellaneous equations. The first type is solving polynomial equations by factoring. Well, polynomial equations are really just equations that have degrees that are higher than quadratics, but a quadratic would be considered, even a linear would be considered a polynomial. So the general form for polynomial may look a little intimidating, but it's basically just saying a variable raised to a number plus a variable raised to another number plus the variable raised to another number, and the a sub n's, a sub n minus 1s, those things are just coefficients. So let's look at how to solve polynomial equations by factoring. The very first thing that you need to do is get in general form. In general form just means that you want to move all the terms to one side and then have 0 on the other side. So if you have a number that's not 0, you need to get that over to the right. The second thing that you want to do is factor out the GCF, or the greatest common factor, if possible. Some of them will have it and some of them won't. Once you take out the GCF, and not all of them will have a GCF, you have to take a look at what kind of terms you have left or how many you have left. Your first option is, if you have 2 terms left. Well, what do you do if you have 2 terms left? If you have 2 terms left, you should look at maybe factoring by the sum and difference of cubes. Well, recall, for the sum of cubes, which is a cubed plus b cubed, that factored as a plus b times a squared minus ab plus b squared. The difference of cubes, which is a cubed minus b cubed, that factored as a minus b times a squared plus ab plus b squared. Right, so just FYI, the sum and difference of cubes are right here if those formulas have escaped your memory. Now, if you have 3 terms left, so you've taken out your GCF if that was possible, you have 3 terms left, you need to look at maybe factoring like you do trinomials. So factor by guess and check, factor by bottoms up, or any of your favorite factoring methods. If you have 4 terms left, well then that's an automatic factor by grouping, and you would handle those problems like that. Once you've factored, so once you've gone through step C, you have to take a look at everything you've just done and make sure that everything is prime, which means that it's been factored completely. If it's not, you have to go back up to step C and do everything again. When you get everything prime, and this is step E, once you're all done, everything's been factored completely, you're going to set each one of those factors equal to 0 and solve for the variable. So let's take a look at factoring some polynomial equations. Here's our first one, example 1. We have 6x cubed plus 2x squared minus 8x is equal to 0. This is a polynomial equation. Well, we want to solve this polynomial equation. The very first thing that we need to do is check and make sure that we're in general form. Well, do I have all terms on one side and 0 on the other side? I do, so I'm in general form. Step 2 said to factor out the greatest common factor possible. We'll take a look at 6x cubed, 2x squared, and negative 8x. Do they have anything in common? They do. They have a greatest common factor of 2x. So let's go ahead and factor out the 2x. If I were to factor out the 2x, I would be left with 3x squared plus x minus 4 equals 0. So once I factor out the 2x, I'm left with 3x squared plus x minus 4 is equal to 0. Now step C says, take a look at what you have left and factor it accordingly. Well, what I have left is 3x squared plus x minus 4. That has 3 terms, so I need to factor it like a trinomial. Again, I factor things like that as guess and check, so I'm going to go ahead and bring this down and try to factor this trinomial. So the only things that multiply to 3x squared are going to be 3x and x, and then we need to multiply to 4 and then subtract to positive x. So let's go ahead and try plus 4 here and minus 1, because 1 times 4 is 4. Let's just check this in our head to make sure it works. 3x times x gives me 3x squared. 3x times 4, that's 12, so that is not going to work. So I'm going to try rewriting this the other way. I'm going to try my plus 4 here and my minus 1. Let's try this again. 3x times x is 3x squared. 3x times negative 1 is minus 3x. 4 times x is plus 4x. So a negative 3x plus a 4x gives me that positive x I was looking for. And 4 times negative 1 is 4. Great. So we've done that. Now it says, step D, ensure that all the factors you have are prime. Well, is 2x prime? Yes, I can't factor that further. So is 3x plus 4, and so is x minus 1. So now what I need to do is set every factor equal to 0 and solve each one of these for x. So I get 2x is equal to 0, 3x plus 4 is equal to 0, x minus 1 is equal to 0. Solving all of these, the first one I get x is equal to 0. My second one I get that x is equal to negative 4/3. And the very last one I get that x is equal to 1. So again, I have three different answers, and my solution set would be negative 4/3, 0, and 1. Let's look at example 2. Example 2, same thing, I'm solving this polynomial by factoring. Step 1 says get in general form. Well, am I in general form? Do I have all the terms on one side and 0 on the other? I don't, so what I need to do is I need to move this 5 over to the left-hand side. So we add 5 to both sides and we get 2x cubed minus 5x squared minus 2x plus 5 is equal to 0. Step B says, well, take a look at the greatest common factor. Well, do I have a greatest common factor between 2x cubed, 5x squared, negative 2x, and 5? I don't, so I skip that. Step C says to factor the remaining polynomial depending on the number of terms I have left. Well, I take a look at this and I have 4 terms left, so I really need to try to factor this by grouping. If I group the first two terms together, and then if I group the last two terms together, let's see if I can factor out a GCF between them. Well, between 2x cubed and negative 5x squared, they both have an x squared as a GCF. If I factor that out, I'm left with 2x minus 5. Now what I want to do is generate the same binomial by factoring out a GCF from the other side. Well, I have a 2x plus 5 and I need a 2x minus 5. I can always factor out a negative 1 from the negative 2x plus 5. If I factor out a negative 1 from a negative 2x, I'm left with a positive 2x. And if I factor out a negative 1 from a positive 5, I'm left with a negative 5. So I end up generating the same common binomial of 2x minus 5. So I was able to generate the same binomial on both sides. Well, let's finish up factoring by grouping. Let's factor out that 2x minus 5. If I factor out the 2x minus 5 from each one of those terms, I'm left with my x squared minus 1 and then equals 0. Great. Step D, ensure that all the factors that you just have are prime. Well, let's take a look. 2x minus 5, is that prime? Yes. What about x squared minus 1? No, that's the difference of squares. I can factor that further, so let's go ahead and bring down my 2x minus 5, and let's factor x squared minus 1. Again, that's the difference of squares, so it factors as x minus 1 and x plus 1 equals 0. Back to the same question. Are every single one of these factors now prime? Yes, yes, and yes. So go ahead and set each one of these equal to 0 and solve all of them for x. And I end up here with 2x is equal to 5, x is equal to 5 halves. Here I end up with x is equal to 1, and there x is equal to negative 1. So I have three answers, negative 1, 1, and 5 halves. So my solution set is negative 1, 1, and 5 halves. The next video is going to deal with solving radical equations.